For basically all of human history, we've been chasing one single, impossible-sounding dream: to conquer aging, right? We've dreamed up fountains of youth, elixirs of life, but what if the answer wasn't hidden in some mythical spring, but was actually being coded onto the blockchain? Today, we're diving into how this really radical new movement is using crypto to fund the science of living forever, and why the old-school institutions we've trusted for decades are kind of being left in the dust. This right here is the big, disruptive idea at the very heart of what we're talking about today. It's this wild merger of cutting-edge biology with decentralized tech. And it's all designed specifically to get around the exact systems that have slowed down our quest to solve aging, which is, maybe the most fundamental challenge in human history. So here's our game plan. We're going to start by looking at why traditional science just isn't getting the job done. Then we'll unpack this revolutionary solution called DeSci. We'll see how it's being aimed squarely at radical life extension, hear from the actual pioneers on the front lines, and then finally, we'll try to figure out what it all means for, well, the future of all of us. Okay, so to really get why we even need a revolution, you first have to understand what's broken. For decades, the engine that powers scientific discovery has been running on this model that is, frankly, just sputtering out, especially when it's up against a massive goal like curing aging. Now, this lays out the conflict perfectly. On one side, you've got trad-sci, traditional science. It's centralized, which really just means a few powerful gatekeepers control all the money and the access. It's incredibly slow, just buried in bureaucracy. And it's closed, with all this crucial data locked away from the public. But on the other side, you've got the challenger, DeSci, decentralized science. And it's built from the ground up to be open, super fast, and driven by a whole global community. Yeah, the old system is just full of problems that actively stop progress. Getting a grant is painfully slow, and it's usually biased towards safe, tiny projects, not the huge breakthroughs. Big institutions? They have a massive conflict of interest. They'd often rather have profitable, lifelong treatments than a real one-and-done cure. And then you've got all this data just locked up, preventing people from working together. And get this illustrates the reproducibility crisis. An absolutely staggering 70% of researchers say they can't even replicate another scientist's experiments. The system isn't just slow, it's fundamentally broken. But, and here's the good news, out of all that frustration, a powerful new model is taking shape. This is the DeSci revolution. It's using the tools of Web3, that next version of the internet built on decentralization, to basically hit the reset button on the entire scientific method. So what in the world is DeSci? Well, at its core, it's a movement to build a more open, a more fair, and a way more efficient system for doing science. It uses blockchain for transparent, unchangeable records. It uses smart contracts, which are basically just self-executing digital agreements, to automate things like funding. And it uses these new things called DAOs, or Decentralized Autonomous Organizations, to let a global community, anyone, govern research decisions directly. So yeah, the old system is broken, but this new movement is literally using crypto to reboot science itself. If you're excited to see exactly how this all works, this is a really great time to hit like and subscribe so you don't miss our deep dives into what the future holds.
Okay, let's get into the nitty-gritty. So a researcher from literally anywhere in the world can submit an idea straight to a DAO's global community. Then, the token holders, you can think of them like decentralized shareholders voting on where to go, they decide which high-risk, high-reward projects get the money. If they make a discovery, that intellectual property can be turned into an IP-NFT, a tradable digital asset that makes the idea itself valuable. And this is the key. The results get published on the blockchain, creating this open, permanent record for anyone to see and build on top of. And hey, don't think this is just a theory. This is a real, rapidly expanding ecosystem that's happening right now. You've got Vita DAO with a market cap over $45 million, laser-focused on longevity. You have Molecule Protocol, which is building the whole infrastructure for these IP-NFTs. They've already created over 150 of them. You've got DAOs tackling everything from data gaps in women's health to open-source publishing. This is way more than just a handful of projects. It's a full-blown alternative to traditional science. Now, let's tie this all back to our main theme. Because really, there is no better, no higher stakes test for this new model of science than one of humanity's oldest and toughest challenges, reversing the biology of aging itself. This is the ultimate proving ground. And this is where it gets really interesting. Vita DAO, the biggest longevity DAO, has raised over $10 million to fund this kind of early-stage research. But look who's involved. Pfizer Ventures,
I mean, when big pharma shows up to the party, you know it's not just some niche experiment anymore. It's a huge signal that even the biggest players in the old system know that this new decentralized model can find breakthroughs that their own rigid systems would probably miss. And who's making these huge funding decisions? It's not some small committee in a locked room. It's a global community of over 15,000 members. We're talking scientists, regular enthusiasts, investors, all voting on which rejuvenation therapies actually get funded. This is what the democratization of science actually looks like. So, what's the wild science at the middle of all this? Well, one of the most promising fields is called cellular reprogramming. Here's the best way to think about it. Imagine your DNA is your cell's hardware. The epigenome is the software that tells that hardware what to do. As we get older, that software gets buggy, corrupted. Cellular reprogramming is a technology that can pretty much hit reset on that software, bringing cells back to a younger, healthier state. And this isn't science fiction. This technology is growing up at an incredible speed. It all started back in 2006 with a Nobel Prize-winning discovery. Just 10 years later, scientists proved it could work in a living animal. And today, a company called Life Biosciences has the first ever partial reprogramming therapy cleared by the FDA to go into human clinical trials. This is literally moving from the lab to the clinic as we speak. All right, so don't just take my word for it. Let's hear directly from some of the pioneers who are actually building this future. These are the scientists and CEOs on the absolute cutting edge of this stuff. This quote from Vittorio Sebastiano, this is a massive shift in thinking. For centuries, we've just assumed aging is simple, irreversible damage, just wear and tear. But he's arguing it's an active biological program. And hey, if it's a program, that means we can learn to rewrite the code. Okay, but with a technology this powerful, safety's everything, right? Joe Betts-LaCroix of Retro Biosciences explains their strategy, which is critical. They take a patient's cells out of the body, reprogram them in a super-controlled lab environment to make sure everything's perfect, and then put them back in. It's a really smart way to manage the risks. And Sharon Rosenzweig-Lipson brings us back to Earth with the real-world challenges. The science might be moving at lightning speed, but getting a totally new kind of therapy to market means dealing with a super complex regulatory system. They are, and I mean this literally, writing the rulebook with the FDA as they go along. And this quote from Yuri Dagan at YouthBio, this brings our whole story full circle. What is the single biggest bottleneck holding back progress? For so many of these incredible companies, it's still funding. Not having enough capital is what's stopping them from moving faster and tackling more diseases at the same time, which is the exact problem that decentralized science was built to solve. So, where does this all lead? Let's zoom out for a second and look at the absolutely staggering economic and societal shifts that this revolution is about to kick off. We are talking about a $33 trillion global longevity economy. I mean, to put that number into perspective, that is projected to be larger than the entire economies of the United States and China combined. The demand for solutions that extend not just our lifespan, but our health span is creating one of the biggest economic opportunities in human history. And this quote just perfectly captures the mind-blowing long-term vision. The team at Molecule Protocol calls it the scientific singularity. It's this future where all these powerful technologies, AI for discovery, blockchain for funding and proof, all come together and create an explosion of progress, an acceleration of science that is beyond what we can even wrap our heads around today. From DAOs to cellular reprogramming, this whole new frontier is evolving at light speed. Before we leave you with one last big thought, if this explainer has expanded your mind a bit, please share it. And let us know in the comments what kind of future you think DeSci is going to build. So, in the end, we're left with this really provocative question. Are we witnessing the exact moment where the secrets to a longer, healthier life are finally being pried out of corporate vaults and placed onto an open, transparent, community-owned network for all of humanity to share? The answer to that question could very well define our future.